Hi everyone, welcome to our learning video sessions on Microsoft Excel for chemical engineers. This video lesson teaches how to use Microsoft Excel software for nonlinear regression and the least square method. In our previous video lesson, we learned how to use the trendline tool in Microsoft Excel for data fitting by using linear regression. We can use the same tool for nonlinear data fitting as well. Now on the screen, you can see some data between two variables. First, let's create the scatter diagram for these data. We learned how to generate scatter diagrams in our previous videos. When we closely look at this scatter diagram, we can see that y-axis values are increasing at a diminishing rate with respect to the x-axis values. So it's clear that the relationship between the two variables are not a linear form. Let's adjust the scatter diagram to make it more clear. We can do that by finding the minimum values of each variable. Let's adjust the axis ranges at the minimum values. We can right-click on each axis and click on Format Axis, then change the axis minimum values. So the minimum values are 50 for the x-axis and 6600 for the y-axis. So now we can see a clear scatter distribution. Now we are sure that this is not a linear relationship, but we don't know the exact form of curve that fits into this scatter distribution. Let's try to place a trend line that can approximately fit to this. So right-click and go to Add Trend Line option. If we observe closely, we can see that the scatter distribution can only match with the logarithmic form from the available curve types in Microsoft Excel. So let's add the logarithmic trend line. Don't forget to mark the options to display equation and r-squared value. We can see that the r-squared value is closer to 1. So we can decide that the curve fitting is correct. Next, let's look at how we can apply the least square method in Excel software to fit some available data to a known form of equation. Now, from the nonlinear regression result, we can see that the general form of the equation for this example is y is equal to a natural log of x plus b. So we can use the least square method to find simple a and simple b values to fit the equation. Let's first take simple a and simple b values as 1 and 1. These values are just an assumption for initial values. You can make any assumption for these initial values. Then let's find the assumed values of y. Y assumed equals to the assumed cell for a times natural log of x plus the cell for assumed b. To apply the same calculation for all x values, we need to fix the assumed value cells. So we can use $mark to fix any cell in a calculation. Then let's find the difference between the actual y value and the assumed y value. To avoid negative marks in the differences, we need to take the square value of the difference. So we take the square of the difference between actual y value and assumed y value. Then let's find the sum of the square error or square difference. In our second video lesson, we discussed the solver tool in Excel software to change values in some cells and make a target cell into some value. Similarly, we are going to use the solver tool in Excel software to find simple a and simple b values to be the minimum square error. Click in the solver tool. Select the objective cell as the sum of square differences to be minimum. Mark the changing cells as simple a and simple b cells. Check out the option to make unconstrained variables to be non-negative. Then click on Solve button. We can see that the minimum square difference is not close to 0, but the a and b coefficient values from the least square method are very close to the coefficient values found from the previous trendline fitting. The capital R square value or the mean square error value can also be found manually. The R squared equals to 1 minus sum of square error divided by sum of square of y minus sum of square y divided by the number of data points. So let's insert another column and find the y square and find the sum of y square. Number of the data points can be found using the count function. Now let's apply the calculation formula for square mean error value. We can see that the square mean error value or capital R value is also very close to the value we obtained from the previous method. That means this data fitting is successful. So from this video lesson, you learned two methods for nonlinear regression to fit an equation for given data using Microsoft Excel. Those are trendline option and the least square method. We can see that Microsoft Excel can help our calculations in different ways and different tools. Therefore, we recommend you to learn Microsoft Excel software for data analysis calculations. That's the end of our 6th video lesson. Have a nice day and goodbye.